Instead of the horizontal steel subgirts and mineral wool being fastened to the exterior or outward side of the sheathing, instead of this being stick-built piece by piece in multiple construction steps, all while struggling for access with expensive aerial lifts and swing scaffolding, instead of this outward assembly being totally dependent on cooperative weather, while it overstretches the capabilities of attentive supervision and quality control, the back-lattice wall assembly is a better wall method of building a panelized wall assembly. Back-lattice is not the wall. It is a better wall assembly method for prefabricated wall panels. With back-lattice, the subgirts and the total continuous insulations are prefabricated and inward of the sheathing. This results in far fewer in-the-field construction steps. The prefabrication and the field finishing are much less weather dependent. Quality control is enhanced during prefabrication, and then when the panels are fully installed just prior to the finished exterior claddings. With back-lattice, our goal is faster, cheaper, better. Hello and welcome to a short presentation which focuses on the framing portion of the back-lattice exterior wall assembly. This is David Schoenhard, the president of Back-Lattice Systems. My over 40 years as an architect and building enclosure specialist has led me to inventing and developing this back-lattice innovative and high-performance wall assembly. In this presentation, we will start by describing the four components of the primary framed panel, then specifically the stud frame. Next, we will describe the sub-girt or back-furring frame, then the thermal isolators, and the fasteners. We'll finish by describing two fabrication methods of assembling the sub-girt frame to the stud frame. The back-lattice primary frame is the thermally broken skeletal frame for the prefabricated wall panel. It consists of four primary components: the stud frame, the sub-girt or back-furring frame, and then at each stud to furring intersection, the thermal isolation pad or thermal break, and the single fastener. Let's start by describing the most basic and traditional component of a light gauge steel stud framed wall: the steel studs. Instead of being spaced to accommodate the cladding, or instead of being spaced to support the wind loading of the gypsum sheathing, the studs are now spaced for their pure structural performance requirements. They are free to be spaced out to 24 inches on center if the loading permits, or 16 inches on center if fire rated. Intentionally, the studs have 2-inch wide flanges in order to support the thermal isolation pads. Studs are expensive, so it helps to be able to space them out for just their structural requirements, and not also for the sheathing or cladding. The sub-girt frame or back-furring consists of 3 specialized shapes, plus any custom shapes specific for a project. The horizontal Z-back is the 1-inch deep Z-shaped typical back-furring. The top and bottom horizontal edges are supported on 1-inch deep J-back furring, while the vertical edges are supported by a simple L-back framing angle. The sub-girt framing is always nominally 1 inch deep and strong in their profiles and materials for accommodating L/600 and L/360 deflections when supporting 20 pounds per square foot cladding dead load. The back furring is typically 18 gauge G60 galvanized in 33 KSI strength. Also available for higher wind loading, such as building corners, is 16 gauge G60 in 50 KSI strength. The back furring shapes are manufactured in Baltimore, Maryland by Clark Dietrich and distributed in the Mid-Atlantic region by Trivdan Building Supply. Back-Lattice includes a nominal markup within the distributor's cost. The shapes may also be self-sourced with a separate markup within the project registration fee. These shapes have been designed, sourced, and tested by Back-Lattice. The horizontal sub-girts or back furring are typically spaced at 24 inches on center, while if fire rated, they are spaced at 16 inches on center. Back furring spacing is also controlled by the wind pressure limitations on the sheathing. With the furring at 24 inches on center and the studs at 24 inches on center, the allowable uniform wind loading is 24 psf. With the furring at 16 inches on center and the studs still at 24 inches on center, the wind loading is 38 psf. At the corners of the building with even greater wind pressure requirements, when the furring is at 16 inches on center, the studs are also at 16 inches on center, and the sheathing fasteners are at 6 inches on center, then the allowable wind loading is 50 psf. While the chart references number 6 fasteners, Back-Lattice only utilizes number 8 sheathing fasteners. Back-Lattice has the ability to accommodate a wide range of wind loadings from 24 psf up to 107 psf. Back-Lattice is remarkable in its details. Back-Lattice has true thermal isolation pads at R1.55, which more than complies with ASHRAE's thermal break. It has no through fasteners, only incremental. Thus, the wall assembly has been thermally proven to be a high-performance wall assembly worthy of net zero energy, passive house, ASHRAE's 189, and LEED. The T-Pad brand thermal isolators are high density, 560 psi, and 1/2 inch thick, as made for Back-Lattice by Armatherm and distributed through either Armatherm or Trivdan. They are available in 2 convenient shapes plus custom as a project may require. Each back furring to stud intersection is separated by a thermal isolation pad to assure a true thermal break. The T-Pad brand thermal isolators are 1/2 inch thick by 2 inch wide nominally, or 1 7/8 actually. They are available in either continuous 8-foot long strips or in 8-foot long strips that are factory cross-scored to field break into individual 6-inch long pads. As introduced above, Option 1 assembles the sub-girt framing directly atop the thermal isolators and studs. The Z-back is the typical horizontal back furring. The top and bottom horizontal edges are supported by J-back furring, while the vertical edges are supported by a simple L-back framing angle. Each back furring to stud intersection is separated with a 1/2 inch deep thermal isolation pad and then secured with only a single number 12 hex washer self-drilling fastener. As a second prefabrication method, this option 2 prefabricates a separate sub-girt frame assembly before securing it upon thermal isolators to the stud frame. This is referred to as the frame-on-frame method. The typical horizontal Z-back and the horizontal edge J-back furring shapes are still utilized, but along the vertical edges, instead of the L-shaped framing angle, a vertical J-back is utilized, which presents a fastening back flange in addition to a front fastening leg. In the frame-on-frame approach, the vertical jam studs are wider at 2.5 to 3 inches to accommodate the fastening of the J-back, but they are often wider anyway due to their increased structural loading. Utilizing stacked double studs is discouraged because they are difficult to insulate between. Back-Lattice has thought through and tested all the little details. The Back-Lattice wall assembly method of prefabricating the primary frame consists of the stud frame with the sub-girt frame, separated by thermal isolation pads and fastened with a single fastener at each intersection. This may be fabricated together as one assembly or fabricated as 2 pre-framed assemblies that are then joined together. The primary frame is located inward of the exterior sheathing, which will be described further in our next presentation. This concludes our overview of the Back-Lattice wall assembly's primary framed panel. Back-Lattice is so innovative in its design, how it places the primary wall performance components inward of the sheathing, that we say Back-Lattice is back fusion for the exterior wall. Our goal is that Back-Lattice is cheaper, faster, and better. So, until our next presentation, thanks for joining us.